And hello once again, back with the third video in the series on building your own drone, in our case a sub 250 gram drone with a frame by Impulse RC, and the frame is a Micro Apex. The flight controller is a Maytech F7 Mini. Right, so in this video we're going to talk about the firmware that's loaded on the board. As I've mentioned before, we had iNav loaded on it. And what we're going to do today is flash a different firmware called Betaflight onto the board, and then later on I'll flash iNav back on. Now, both the firmwares, Betaflight and iNav, very similar. Betaflight most people will use when they're flying a drone, when they've made their own drone and they program or flash the firmware to the board. It'll be Betaflight. But some people will choose to use iNav, which is kind of a derivative of Betaflight. It's called a fork of the Betaflight software development. We'll show you how to download both, and we'll show you how to access or hook up your computer to the board. Now, iNav is, as I previously said, allows you GPS functionality. Betaflight doesn't allow that. So Betaflight is simpler, but doesn't have GPS. So let's get into it. So there's the board there, and we have, let's find out where our first thing is. Now, got a whole stack of tabs open here. And the first one is Flight Control, as explained. It's by a guy called Oscar Liang. I've never met the gentleman, but it tells you, it gives a history of the different flight controllers. This flight controller here is an F7, whereas other drones that I've got are F4 based, and I don't have any F1 or F3, and I certainly don't have H7. This is an F7 board, and you can see the URL. Can't see the URL, but there's the URL is just there. I'll get rid of you. It'll raise the camera. And you can see if you need to access this particular page, there's the internet address up there. So it's on flight controllers, and it talks about sort of a little bit of a history of them, what they are, and pretty much what we're up to, FC being flight controller there. That's a worthwhile site having a look at. I don't get too much into the technical side, but it's important that you know what firmware is. It's called a target, what the target is, what particular board, a Maytech, in this case a Maytech Mini F7. You have to keep that at the back of your mind. Right, and that there is for this particular board. So it's an F7 22 Mini SE. And you can see from here, it's the board is between the mounting holes is 20 millimeters by 20 millimeters. This is for the inner part. And the outer part is, I think, 30 by 30 millimeters, in case you have a slightly bigger drone. But for this very small drone, I needed the 20 millimeter by 20 millimeter. Once again, there's Maytech, a reputable brand. And in here, it's got all the bits and pieces we need for hooking up to it. With our GPS and our electronic speed controller and our GPS. Now when we go into the software, I'll show you in Betaflight what's called the configurator, where you actually do some of these settings, depending if you've got, they're called UARTs. If you want to hook up a GPS to a UART or a camera to a UART. A UART is just a communications port. I think it stands for something like Universal Asynchronous Receive Transmit, whatever that means. These other tabs here, I've got different USB driver downloads, which you'll need, and one's from Impulse RC, and it's called Driver Fixer. and the other one is Zadig, and people use both to actually allow your computer to talk to the flight controller, because sometimes it just doesn't want to talk. And we'll see if we have any hassles with that. All right, so the first thing is with our configurator, with our software that's sitting on there, I've got iNav sitting on at the moment. So I'm going to see if I can hook up to it. Now I haven't actually configured this board. I have, and I've flown with it, but I've loaded Betaflight on it and then loaded iNav back on it and lost the initial Betaflight settings, which is good. So here's iNav down here, this blue little icon down here. Get rid of that. Wait for iNav to load. And there's iNav there. Notice the blue screen. Let's have a look around there. Let's have a look around. Now, what we've got is, it tells us what, this is called the configurator. It's a software that allows you to flash firmware to the board. So the configurator and the software, the firmware, go hand in hand. This used to be, or certainly Betaflight did, used to be a Chrome extension. So it would run underneath Chrome. But now they're standalone installations. You download the configurator and install it. It's going to minimize that for the moment. So here's where you find it. Okay, I just search iNav GitHub. Now, GitHub is a repository for software. So lots of developers put their software on GitHub, and then from there, other developers, if it's open source, will do different versions of it, or take the software in a whole different direction, called a fork of the software. Yeah, so I googled that, and this is what it came up with. Okay, when you choose the particular, I think it's that first link there, and you can see there's URL, so you don't even have to Google it, you can just type that in. So I have 3.0.1, and blah 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 blah, some upgrades, some bits and pieces, what it supports, some new targets that it's added. So these are all flight controllers, a diatone Mamba F405, so that's an F4 flight controller. Flywoo F4 controller, you can see there's a Mamba, a different brand, F7, a Maytech H7 brand. I know nothing about H series of flight controllers. They must be U-Butte, I guess, in you. The settings are there, blah, 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 blah. I'm not even going to bother reading those. And down here are the actual hexadecimal files. This is the firmware. Now, you can download, this is not the configurator firmware. These ones here, these hex files, are actually the firmware for the board. And when we would go into the configurator, we would access this particular firmware. We would save this, see if we can find Maytech. Here's Maytech. Maytech, okay, iNav 3.0.1, Maytech F722 Mini. So this is the hex file, and I would save this to my hard drive. Then in the configurator, in the iNav configurator, I'd come back and I'd point it towards that and load that. Okay, that's all the changes. So, but there's another way to load the firmware too. Straight from iNav. You can get it to go and find that file. I'll show you how to do that. All the different changes to it. And this is all free software that the developers and people have done. Continually improving the product. Okay. Lots and 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 lots. Some sort of patch. And what I'm looking for, so that page there is the iNav, all the targets for the different flight controllers. Now this one here, I googled INAV configurator. Maybe I did that before. Can't remember. INAV configurator. Because I actually want the the software sitting on my computer that I can actually use to access the board. Let's go to it. See what it says. Get rid of that other one just so that it's not confusing to me. Get rid of that. Okay, so it tells me my blah blah, a little bit of a blurb. How to install it. There's a YouTube there. More developer stuff which doesn't concern me. Some credits. And I'm looking for where the software is. Okay, so let's go Windows release page. I'm using Windows, but there's Linux or Linux and there's Mac there too. Okay, INAV configurator. Finding where the now has H7 flight controller support. So those with H7 flight controllers can use it. Again, there's it's got recommended hardware. So when I was deciding what board to get, I certainly looked at this and said, yep, because I want to run INAV, because I want to do GPS navigation. I'll need a board that can support INAV, because not every board can, and this one certainly can. And I did my research and said, well, can a GPS hook up to this? Yes, it can. Has it got a barometer for altitude input? Yes, it has. It's got a little barrow. Okay, and you can also use INAV for fixed wing. A lot of people use it for fixed wing, to stabilize the aircraft and for GPS waypoint navigation. Okay. And there we go. It took me a long time to find it, but there is the configurator. Now I wanted the Win64 because I got a 64-bit laptop, as most people would. And you pick it up from there. Right here. So we have, pretend we have downloaded it, all goods, and run the software. And up pops the software, the configurator. So let's have a look around the software. I appreciate your patience. Up here we've got, will appear what port the flight controller gets connected to. Now when it says this, it means it's not seeing, the computer's not seeing the flight controller, but I haven't plugged it in with my USB in the first place. We've got our baud rate. If you remember, baud, B-A-U-D, baud is bits per second. And because we're doing a wide connection, it's 115,200 baud. But if you remember back to the old dial-up modem days, they were 9,600 baud bits per second. Other parts, there's a connect button. It tells me what over here, top left, what version I've got, 3.0.1. And if you had an older version of INAV and there was new versions available, if you started your old version, like I did, I had 3.0.0, I think, before. And when I started it, it told me there's a new version, and I had to download it. It wouldn't let me do anything else except download it. Down here, bottom left, is firmware flasher. Now INAV is also good because it has, it's got a ground control station as part of it as well, which Betaflight doesn't. So I can control missions from INAV, which is what I want to do. I can have a map with my waypoints on it and see a little icon of the aircraft moving around the map. Sort of like or just like Mission Planner for those who use APM and Pixhawks and Mission Planner. Okay, so what I'm going to do, now I'll show you some of the errors that will happen. I'm going to hook up my flight controller. Now, just bear with me while I get stuff sorted. I'm going to make this a lot smaller and just move him somewhere. Maybe just here out of the way. Right, hook up my flight controller. Now we'll see what it does up here. It says it's port /dev /dev /rfcom0. Okay, power going in, lights coming on, just here. Oh, good. It says it's mounted as COM11, COM port 11. Remember how you COM ports on your computer. If I if I put a different device on here, maybe a mouse or maybe a modem or a different flight controller, it would mount them as different COM ports. Okay, if I go connect, and remembering this has not been configured yet. So when I configure it, I get a little picture of a drone here. But to start off with, well, I'll show you what I mean anyway. Connect. And because this is a blank flight controller, I start by configuring it. So I know I'm going to be using it for, these are 3-inch props. So I'm going to click on that and just let it go from there. That is not a drone, it's a block of a drone. Let's see why. Okay, and if I move this, you can see me sort of jiggling it. And which way is forward? That's forward that way. If I pitch, it pitches. If I roll left, it rolls. If I yaw left, it yaws. That's all those things. Isn't that good? And as I go through this calibration, all these configuration tiles or options on the side, at some stage it'll come up with, probably when I calibrate the accelerometer and the gyro. Okay. And there's a process there. But we'll go through those at another time. At the moment, we're just looking at flight controllers. But there's all sorts of good gear here that we'll do. Ports, fail-safe, what do you want it to do when it loses radio communication? Do you just want to fly away, kill lots of children? Do you need to fly into a car and cause havoc on the interstate? But all this stuff we'll be doing. What sort of receiver I've got it attached to? Not attached to anything. Okay. Now this one here, this ports is very important. These are UARTs. So this is where all these different devices are connected to different UARTs. What I'm trying to do is get all these really confusing, and I'm probably not going to do it very successfully, but all these confusing things to do with the flight control, to do with the drone, and try to bring them in kind of some semi-logical or semi-confusing way, so that they make sense at some stage of your journey. So here's my GPS, plugs in there. And it connects to a UART underneath. It's soldered on. My receiver, my TBS Crossfire Nano receiver is connected to a UART, the communications port. My video transmitter, my 5.8 gigahertz video transmitter. Oops. Yeah, it's cool. It's not transmitting at the moment. I've only just got USB power going into it, so it's fine. You should always have your, I'm going to put it on anyway, your antenna on. I mentioned that before. But it's cool, so it's not overheating. I don't think there's any power going into it. But it's connected to a UART. Now, why would you have, as an example, a video transmitter connected to a UART? Well, the flight controller is overlaying information on the video signal, some sort of video telemetry. And for your Unit 2, Emerging Aerospace Technologies, or whatever you might be doing in Year 8 or 9 or 10 STEM, Year 11 Aerospace, you can start talking about things like telemetry and where missions are conducted from the ground control station, like INAV. Okay, it's one of the topics in Unit 2, and what telemetry means coming in to your ground control station, and why you'd want information about distance and height. Isn't the drone taking care of all that? You know, location. Well, I suppose it's always good to know where the drone is when you're flying it. It certainly is. And battery information coming back, so you can start monitoring all those parameters associated with the drone. Okay, so and that can be overlaid on the video signal, which is interesting in itself. I'm probably digressing a little bit, but remember I talked about ACMA, Australian Communications and Media Authority, the other day? Well, the class license for 5.8 gigahertz is 25 milliwatts. I said 25 piddly-watts because it'll take you 100 meters on a good day, probably not even that. But because we're overlaying telemetry on the video signal, the ACMA do allow up to 1 watt for telemetry data, for telemetry, to output your video as telemetry. Now, there's a lot of argument about whether that's legal or not, but officially that's what I've heard, so that's what I'm sticking to. So we could bump this up from 25 milliwatts maybe to the next one, which is 100 milliwatts of power, and then 200 milliwatts, and then so forth. So no way would I be putting, this little video transmitter can't go to a watt anyway, but it certainly can go to probably 400 milliwatts. Remember, double the power, like from 200 to 400 milliwatts, is not double the distance, and that's a whole different conversation in itself. Right, so we've done that. We've connected. We've had a look at a few things. Had a look at these UARTs where my peripheral devices will be connected to. So just keep it. Basically, all I want you to remember is those UART numbers are very, very significant. Okay. That's about all I want out of iNav, I think. I don't think there's too much else I want to talk to you at the moment about iNav, because we are going to, because this video is not really about the actual configuration of it, it's really just about the flight controller and how to load software. I'm going to attempt to load Betaflight back onto it, get rid of iNav. Right, and then maybe in a couple of weeks or a month or so, we'll go back to iNav when we're ready to do the video on iNav. But to get you up and running, I reckon Betaflight's the first stop. Basically, that's what you want to do, is fly Betaflight first, and then later on something more advanced, which is iNav. Okay, so Betaflight. Right, we need, okay. That's what I forgot to tell you in iNav. One more thing before going to Betaflight. Let's load iNav again. This video is going to be warts and all. It's not rehearsed. Don't have time to rehearse stuff. Okay. I didn't have to click on anything. It just came. It saw COM11. Now, I was just going to tell you really quickly about flashing the firmware. But we'll be doing the identical thing in Betaflight. But what I could do is go firmware flasher, click, get all sorts of warnings. And this is where I choose a board and what firmware version. I want full chip erase, I want to erase the chip, and everything else I'm leaving as stock. Now remember I said before that you could get the firmware target, and we saw those in one of the screens here. Or that's where you saved it, that hex file, that .hex hexadecimal file, which for all you maths kids out there is base 16 hexadecimal. Don't need to know about that though at all. And you would load it. You go load firmware, and your computer would go out, blah blah blah, and you would go looking for it. There it is. Right? And, I had downloaded it. Notice the version. It matches up to the configurator. And I would go open, and then from there I would flash it under here. I'm not going to do that. I'm going to go choose a board. I'm pretending I haven't downloaded. Choose a board. This is MateTech F7 22 Mini, just here. It says what firmware version. So you don't have to go for the latest. One of my Cinewalks is running. It's an F4 board and it's running old F4 firmware, but it works really well with it. And I'm just not going to upgrade it just to see if it'll go better. Something will go wrong for sure, and it won't fly as well as it should. I'm not willing to risk that. This is a brand new upgrade. This is a brand new flashing, so I'd go that one. It says it's stable, a stable release. You could go show unstable releases, right? And then it would put in those beta releases with some sort of whiz bang, all singing, all dancing functionality. See if it does. No, Oh, there it is. I think it's that, a release candidate, you know, something that's up there for release, but not just yet. And those candidates aren't shown when you yeah, they're all the stable ones. They're proven. There it is. Good. Notice that button down here has just gone from grey to blue. I'd go loading, and then I'd flash the firmware. Alright, shall we reflash it? Why not? Why not? Just to show you what it does. Flash firmware. Right. I'm glad this happened, and it didn't work. Right. This thing popped up again. So I know from experience. So just you've got to be prepared that this is going to be a journey, and things aren't going to work straight away. It didn't flash the firmware. It said failed to flash. It had a problem. Had a hissy fit. Spat the dummy. But we can get around that, and that's where we bring into where we might need to use these two babies here. These USB drivers, because the existing Windows USB drivers, it doesn't work, or it doesn't like it, can't use it. And these will change the driver to something that can, software drivers just, like Windows drivers, so that the computer can talk to the piece of electronics or piece of hardware, whatever it is. But I do know, so that's my backup, is to use one of those. I'm going to disconnect. You should see the light go out. Hold the boot button in. Now there's the boot button just there on this board. Just there. And my thumb is where my screwdriver is. Just there. An option is to hold that in. It's got to go into boot, what's called bootloader mode. And if that works, when I plug this in, if that works, I won't have to use Zadig or the impulse driver manager thingy bob. Right? It'll come up here with DFU mode. I don't know what DFU mode is, but it's a good mode. It's a happy mode. Here we go. I'm holding that boot button in. Look for DFU mode up there. And if that doesn't work, and it didn't work, it worked yesterday, didn't work today, I'm going to try it again. If that doesn't work, I'm going to reboot iNav and reboot everything. We try again. We never give up, ever in this game. Ever, 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 ever do we give up. Let's try again. Button in. Oh, look how fast that changed over to DFU mode. Go figure. I had to reflash the configurator. I'm happy. DFU mode. It's got to be an acronym for something with goodness in it. Okay. Let's go firmware flash up. Because I'm in DFU mode, it's going to be happy days. Maytech F722 Mini version, latest one. Full chip erase, load firmware unload, or go and get the hex file that you downloaded. But this does it for you anyway. Flashing firmware, erasing. When you see that, you're halfway to doing it. But I have been here before where it says unable to flash. But this is going to work because we're in DFU mode and it's going to be happy. It tells you sort of what to do through here if it doesn't want to talk, if your computer doesn't want to talk to the jolly board. And it mentions Zadig in here and these USB drivers, STM32. Verify, programming successful, happy day. So we have loaded the firmware version 3.0.1 of iNav onto this board. Having done that, we're going to now put Betaflight on there and get rid of iNav. Why? Because I'm stupid. No, I'm a glutton for punishment. No, because you've got to push yourself to do these things. Right, Betaflight. You need the configurator, Betaflight configurator. There it is in GitHub. And the configurator should find the firmware file. You need the latest one, just like iNav. I've got the latest one. Here it is. It's got a picture of a wasp, kind of a yellowy golden wasp on a black background. So you can find the URL. Okay, easy to find. Want me to click on it? I know you do. Okay, there's the latest one, 10.7, and I've got 10.7 loaded here. I won't go into that. And of course, Betaflight's got all its targets. Get rid of all this, not needed anymore. So let's start Betaflight. Maybe some call it Betaflight. I've got no idea what it is. It's Betaflight. There it is. Now, if you look at that and then you look at iNav, you go, they look very similar, except the colours are different. So it's Betaflight's colour, iNav is blue. Isn't that cool? That's why I like this kind of open source. You can donate to them. I haven't. I should, but I haven't ever. Don't tell them. Wonderful, wonderful people, whoever they are. The faceless man of Betaflight. Right, and it looks just the same. There's my, up here, my, what's it called? That thing. Version of the configurator. This is all the same, this is all the same, this is all the same. Right, so we're going to flash Betaflight. Now I'm not plugged in, as you can see, and anything could happen. Firmware flasher. See if you can remember what to do. If you're saying go bottom left, firmware flasher. If you're saying that port thing up there means it's not talking to it yet, you're correct. Now what do I do? Because you're an aerospace or STEM student. Okay, it's remembered what I've got. I'm not even plugged in. F7, I'm not plugged in, but it remembered my last thing. Maytech F7 22 Mini, right? Full chip erase, yep, don't touch anything else. And the latest, right? 4.2.9 is the latest firmware. It's got the date. Look at that, 28th of April, 2021, 0540. It's almost busy in the morning. Right, load firmware online, if that's what you were going to tell me. And if I didn't want to load it, if I wanted to load it locally, what would I do? Go to the right thing, get the right target, download the right target to your hard drive, which would be what kind of file? Hexadecimal file, and then you'll pick it up from there. Right, here we go. Now, I'm not connected here. I'm going to plug in without pressing the button. It says COM11. It's not DFU mode. I'm thinking this won't flash, but I'm going to try it anyway to see if it does. I'm not going to break it. See, it says, it recognizes it, that there's a board there. It's even going to allow me to connect, but it's going to throw up a hissy fit when I try to connect, and I'll do it now. Why is it going to throw up a hissy fit, students? Because non-Betaflight firmware not supported except for CLI mode, command line interface mode. Okay, so it's not, it can talk to the board, but only just, it's just barely communicating with it. Like, hello, hello back to you, hello back to you, hello back to you, and that's, what is that? It's the world's biggest rat I saw in the background. All right, so let's have a little look again. Okay, load the firmware, flash it, and see what happens. No, not happy, Jan. I'm kind of happy that it's not happy because then things, I like consistency. I like to know what to expect. See what I expect. All right, so I'm going to close that. Going to stop that. I'm going to close that. Going to load Betaflight again. you got me saying beta. I'm going to hold the boot button down. See if we can whack it into DFU mode. I think I really like Maytec as a brand. I use some Maytec other things. Maybe Maytec make coffee too. Who knows? But they're wonderful. All right. Firmware flasher. Blah, 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 blah. That's all stock. Don't need to close there. Load firmware. Now, things normally aren't this easy, so I'm fully expecting something to not work. But erasing. The dog is scratching. Whilst doing that, I gotta get the dog, put it up on the couch. It's flashing. It's a really opportune moment for the dog to start scratching on the couch because it wants to get up to it. It's all planned. Everything is a plan. Happy little board. Flashing merrily away. Let's speed up the video now. Programming successful. I salute you. Little F7 board. Good. Right. I'm going to depower. Because it was in DFU mode, and I'm going to plug in. My computer recognizes it as COM port 11, communicating at what? Baud rate. I'm going to commit. There are custom defaults for this board available. Normally a board will not work properly unless custom defaults are applied. Do you want to apply? I'd be an idiot not to, but... Okay, done that. I wonder if it's going to reboot the board for me. It did. Connect. And follow me in the accelerometers. That's fine, all that kind of stuff. When it goes into the drone and it's sitting nice and flat and level, and the drone, you'll do all those kind of things. Hey, but this is giving me this particular thing here. Let's see if it, yes, we've got pitch, roll left, roll right. What's this called? E9 stem. It's your left, your right, your Y-A-W. Your. Okay, and look. It's just like iNav. iNav big flat. This is why this is so good. This is why you should do this. This is why, you know, DJI just doesn't let you do these kind of things that make it so addictive and wonderful. Receiver, look. Where's my file safe? It's going to be here somewhere. It'll pop up. What modes am I going to fly? You know, there's all these different modes that you can add in these in Betaflight and iNav. There's a CLI command line interface. But for these purposes, see, there's no GPS, because this is Betaflight. It's not iNav. We are going to, I'm going to disconnect from there, and I'm going to close you down, and I'm going to pop you out, little board, and that's just about, all we need to know for the moment to be dangerous, to get us up and running. I'm going to show you the bits and pieces. Dog's gone. Back to yell. Beanie! Put a sock in it. Dog at the back fence. One of my year 9 students, Elliot. It's his dog. Elliot, it's your dog barking at my dog. Cause my dog to go ballistic. Do something about your dog, Elliot. Meanwhile, Elliot's going, do something about your dog. Thanks. Right, okay, that's there. Maybe down there just once again. We're just about done here. I'm happy. Right, so there was our page for, there was our page from Oscar Liang. There's some really good YouTubers out there, just absolutely brilliant folk. There's Oscar Liang, subscribe to him. Albert Kim, subscribe to him. Joshua Bardwell, subscribe. Painless 360 English Gentleman, subscribe. Andy RC, English, subscribe to them. Find out, pick their brains. Really, really great. The greats of the hobby compared to us minnows who are just users. Right, so there's my flight controller that I flashed, and there's my boards. Now, while we're here, other components. Can you remember what that was called? With the motors hanging off it. Acronym PDB, Power Distribution Board. Right, yeah? So, and this one, this PDB has also got electronic speed controllers attached to it inside now. I'm just wondering. Yeah, let's do it now. Let's go. With electronic speed controllers, traditionally, be careful just Googling things. Now, that's what they look like over here. This kind of thing, this kind of thing, this kind of thing, this kind of thing. But traditionally, they sit out on each arm of the quad. So if I had there's my arm out here with my motor sitting on the arm, electronic speed controller would be sitting here. And the motor would plug into the ESC, which would plug into your power distribution board. You have a separate thing. Advantages and disadvantages of having them separate. So let's see if there's any pictures. I've seen a picture here. They're all. Is it drained there? Excuse me. It would sit out here on the arm. Here they are. This is what I'm after. You can see them there. 1, 2, 3, 4. Sitting out there on the arms of the drone. So, where's my one? You're asking. Well, these electronic speed controllers are integrated onto the power distribution board. They're not separate units because weight's an issue for me. Have a think about advantages and disadvantages of separate ESCs. Right, you can talk to your teachers about that. Hint, if I burn one out, and you can burn them out, what can you do compared to what I've got here, where they're integrated onto this board? Okay, the part of this. So this is what we've got. This particular one is a 4-in-1 ESC. That's what it says there, with one current sensor on there. You can get other ones with individual current sensors through the individual speed controllers. My one is just a little bit cheaper, doesn't have that. Right. It's got where it plugs into, it'll be on the flight controller where it plugs in, just there. All right, and that's this part here. It'll be printed on the board what all the bits and pieces are. It's got your numbers 1, 2, 3, 4, and it's got some other bits. It's got power, it's got some earth, and it's got some other bits, other lines. But remember, your flight controller is commanding. Power's coming in through here on your power distribution board. And your flight controller is commanding. It's keeping this little drone level through use of its gyros. It's commanding different motors to spin up or spin down, throttle up or throttle down. So hence why you've got this relationship coming in here. Interconnections. Using your habits of a systems thinker. Okay. Yeah, what else have we got here? Let's have a look. So that's there. It's got the settings here that you would put into Betaflight. It's got your connections here for your GPS and where they would solder onto. Yeah? So So here it is, this little one, and I'll show you what type of GPS. It's got an integrated magnetometer on it. Magnetometer. What does magnetism give you? What points to the magnetic north pole? Your compass, right? So I need to have, if I'm doing waypoint navigation, I need to have a compass. I need to have a compass attached. Unlike an aeroplane, if I was running iNav on here, this is an aeroplane, I was running iNav, then the tail is always going to follow the nose, but with a drone that is not necessarily the case. It can fly around like this, rather than an aeroplane flying like that. Yeah, I can make this fly as long as I've got a compass, as long as I know heading. Don't need it for the Betaflight build, but certainly for iNav. Now what have we got down here? What's this particular part? What's this particular part called? That is my ports section in Betaflight or iNav, and with my UARTs. Notice my UART connecting. And here it tells you to connect it on UART1. It's got all the other settings. If I've got it soldered up correctly here into the right ports, so there's earth, positive, a blue wire, yellow wire, green wire, and that's it. Let's have a look here. There they are. There's the wires coming in here. 5 volts is on the red wire, so that's a 5-volt device. Ground. Now this is how UARTs work. Okay. T1 is UART1, as can be seen here. GPS is on UART1, and R1 is receive 1. Now, on your board, you would solder to R1, and that joins on to TX or T1 on the device. And on the board, the flight controller here, T1 UART number 1, the transmit part connects to the RX. It's like voice ears down here, voice ears. So transmit has to be connected to receive. T has to be connected to R on the correct UART port, which is number 1, and then we tell Betaflight number 1. That's not too hard, is it? Took me a little while to understand that concept, but once it did, bing. Now, here is my Crossfire Nano receiver. You can use whatever you want. I think FreeSky, a different transmitter. FreeSky is F port, I think, can't remember for sure. And that's how to connect it up. I'm using TBS, Team Black Sheep Crossfire. I don't have the transmitter here today, but I'm using Crossfire. And that's what CRSF is, Crossfire. Okay, and it tells you how to connect up to the UART port. I think Crossfire, what's it say? Let me just have a read. Betaflight, GPS, have I got that? I have to have a look what port that is. Now don't laugh, I'm going to have a look. I've got a pair of safety glasses with these little magnifiers, cable tied to the front. Works like a champ, or else I can't see. How big do my eyes look like? It's really weird. Can't tell. Can't see, it's all blurry. I can come in here and I can look for my TBS. Yeah, it's on UART. It's on UART 2, just as I thought, which is here. There. Oh, I'm stupid. See, it's got serial RX, that's for your transmitter receiver. You know, your transmitter, gimbals, roll, pitch, fly the thing. It's on there. You don't have to set anything else here because it's on UART2. Just make sure that that button being activated there or enabled is my receiver. But you could put that Crossfire receiver or any of your receiver on any spare UART as long as you do it down, as long as you tell it down here. Now these things, IRC Tramp and SmartPort, are different protocols for doing things. I do have some information on IRC and SmartPort, but I don't know if it's handy here. And whether I should actually do it. SmartPort, see if I can search for it. Yes, okay. Okay. IRC Tramp, Immersion RC, that's just the manufacturer. You use those, like Smart Audio. I think Smart Audio was something that was initially designed for audio, like two-way audio, to get audio back from somewhere. But they found they could use it as a communications channel, so you could actually control things. Picture this: you're flying your drone. You've got your transmitter in your hand. You've configured it all in Betaflight, and you want to. You've got your FPV goggles on. And you want to change the video power output. So rather than actually going to the flight control to the board here and pressing buttons on the video transmitter to change the output power or change the band it's on or the frequency within the 5.8 band, you can actually do it from the transmitter. You can sit there with your goggles on and go use the gimbals and move the gimbals in a certain way, and you can change. I do this for my drones. Okay, you can actually bring up a menu and change the frequency and the power output. If I'm just flying really close to myself, just doing some sort of slow flying around trees, put my video goggles on, I just want to use 25 milliwatt. It's hardly any power. I'm not disturbing anyone. 25 milliwatt ACMA class license, etc., etc. But so I'm flying a bit further away, I might put it on 200 milliwatts. Maybe ducking behind some trees. Maybe one of my transmitters goes up to 600 milliwatts. But you're pumping a lot of heat into that device. It's consuming your battery power, which is the same as your flight battery too. So it's consuming a bit of that power. So there's advantages and disadvantages to using high output powers, of course. And you can configure that from the OSD, the on-screen display in your goggles. So you've got your gimbals in your hand, and with some, for me, I'd fly mode 1, throttle on the right. It's your left and full and pitch forward, and the menu pops up in your goggles. And just looking in your goggles, it's like this little heads-up display here, and then use your right gimbal to scroll down and to select, and you can change your output channels. No wonder we absolutely love this hobby, activity, profession, whatever you want to call it. So those ones there, you can use Smart Audio or IRC Tramp to adjust your video transmitter settings. If there's someone flying next to you, a buddy of yours flying on a particular 5.8 gigahertz band, then, frequency, 5.8 gigahertz is the band, a frequency within there, then you could get them to you can get them to change to a different frequency that doesn't conflict with yours. Okay, so there's my video transmitter there. I did have, yeah, okay, there it is. Can you see that? That's on the 5.8 gigahertz band that we use for video, and the different channels and frequencies within the channel. So on channel A, you got 5,865 megahertz, which is 5.865 gigahertz. So you just, 3 decimal places. Come on, STEM students. You know how to jump decimal places by now. So megahertz is million, gigahertz, billion, 9 zeros. So from mega to giga is an extra 3 zeros. The dog agrees. And channel B, you can see these frequencies are different, but some of them sit really close to each other. So just because you're on a different frequency within the band doesn't mean someone's not going to trash your signal. They will. So you want to they have these things called race bands. It could be R. These could be race bands here. I don't have to double check, like most things, where you're all sufficiently far enough away from each other inside that channel. Right, you can see 5732, 5769. You're not sitting side by side frequency wise and just trashing your signal, especially if you're 25 milliwatts, you're not going to hurt anyone. But anything above that, you know, you can really start trashing. Even if you're well separated, 600 milliwatts, you really could be affecting somebody else within this band, you know, the 5.8 band. Okie dokie, makes sense? Maybe not, but it's all a learning experience. So that was those things there. Now those particular things called smart audio, IRC tramp, and smart port. There we go. See, I take notes. I use OneNote, Microsoft OneNote, for all my workflow, and I take notes of everything, so I can just search for them. What is smart audio and tramp? Smart and smart port. Smart port is a telemetry system by the newer FreeSky transmitters. Okay, such as the with those special receivers. Okay, so you can use smart port as a telemetry system. And that's, again, that just fits so neatly in with Unit 2, you know, your ground control station. It's starting to bring students, starting to think about, it's not just flying a drone, it's I can use these things for some sort of task or some sort of mission and get telemetry back and control my devices from my transmitter. And that kind of technology, it's not expensive, and the software is free. Not FreeSky, FrSky, FreeSky. Okay, what was the next thing? Can I find it, Captain? That's there, you know, you can see there's smart port and IRC tramp sitting on UARTs. Oh, that's sitting on something called soft serial, not going into that there. But this one here sitting on a UART, GPS sitting on a UART. Okay, and I've got that off Maytech. I didn't need to use these ones, right? But keep them in mind just in case you need to replace your driver. Okay, just in case you need to. And I don't particularly, now that everything's working really well, I don't particularly want to. Oh, okay, I'll show you how to do it. I'll show you how, just in case you need them to replace your USB driver. First one's Zadig. I've got Zadig here, I think. There it is, right? If I plug in flight controller and go options, Zadig is the download, just there. All right, so that's where you get it from. You install it. Once the program's running, you list all devices, and yeah, there's my webcam there, and there it is there, STM32. That's the driver for my computer to talk to this flight controller. And I'd go replace driver, and I'd try to see if it worked. I'm not going to do it now. If that doesn't work, first thing is I'd hold that boot button down, but you might not be able to find the boot button. It also, in Betaflight, says that you can short a couple of pads just with a piece of wire, and that puts it into bootloader mode. Just be careful doing that because you might short something else. This has got the boot button, so try the boot button first, try Zadig second. If that doesn't work, try Impulse RC driver fixer. There's the URL there. Remember, Impulse RC, local companies, support them. Brisbane-based companies, support your Australian companies, support your Brisbane-based companies. Driver fixer, just there. I've downloaded that. Up she pops. It's found the thing. It's failed. Sometimes it fails, sometimes it doesn't. I don't mind that it failed at the moment, but I've had success with that one before. Right. I actually don't want it to change the USB driver because it works. Right, and to prove it, just to make sure I haven't stuffed anything up, just replacing the driver. Let's go into Betaflight. Reboot it just by pulling the USB cable out. COM11, connect, all good. I'm talking to it. There it is. Just disconnect. Right. So that's almost all done. I've done Oscar Liang and flight controllers. We've done the UARTs and the 4-in-1, the 4 speed controllers in one on the power distribution board. We've done that. Yeah. Yeah. We've done GPS. Oh, incidentally, yeah, we've talked about UARTs, transmit and receive. That's serial data and serial clock. Those two, SDA and SCL. And on the board, they're called SDA and SCL. You'll see them on the board that you solder to. And where your crossfire receiver or your F-port receiver or your Spectrum receiver, which is S-bus, serial bus. We've done all that, so you can go. We've done that. We've done that. Just some other bits and pieces. That's my 4-in-1 25 amp speed power distribution board, and it's got integrated speed controllers. You'll hear BL Heli mentioned a lot. That's the firmware that sits on a speed controller, BL Heli. I just go with it. Tells you other bits and pieces in there, blah, 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 blah. I'll show you where to buy this kind of stuff. So, your motors will draw a certain amount of current, right? And this is 20. It can, these speed controllers that are on here can take 25 amp out through each particular electronic speed controller on the board. It'd be these chips here. I think they're called MOSFETs, but I'm not sure because I'm not an electronics person. But yeah, 25 amp for each one. So if you put on a huge battery on here that could deliver the current, maybe, like it says 6S, that's 6 lithium cells in series. Each one is 3.7 volts per cell. 18, so what's that, 22 point something? What did I say? 6S, so 42. So 22.2, can't remember. That could push a lot of current through here and go over 25 amp, maybe 35 amp, maybe 50 amp, in which case you'd burn the speed controller out. And then, to answer our question, what's better, a speed controller on the arms, separate. If you had a speed controller just on the arm, not integrated on the PDB, then you just need to swap out the speed controller. But this can take up to 6S. But, I might put like a huge propeller on this, way too big, way too much pitch on it, and go full speed, and that motor will start drawing lots of current, burn out the speed controller, have a hissy fit, drop its guts, and burn out your motor too. So your motors and your props have to be balanced. See how the whole system is related to each other? A propeller too big will draw too much current from your battery. Your battery may or may not be able to deliver that current. It might be able to, and so it does, but the system might not be able to handle it. The wiring might not be able to handle it. The speed controller might not be able to handle it. The motor might not be able to handle it. And we've got ourselves a problem. We have the magic smoke. But you can put the magic smoke back in the device and it fixes it. Right, so that's that one. Okay. You don't need to buy from there. That's the FPV camera here. It can be used in low light conditions. Not cheap. And you buy cheaper ones. Know the dimensions of them because it has to fit inside that particular. So what was the dimensions of this one? It's got the sensor, NTSC or PAL. You've got different colors, so you can use it in low light. Dog. Focal length of the lens, and I'm looking for 1200 TVL television lines. I'm looking for there's dimensions there, and weight as well, because you want to keep our weight. And very importantly, what power can you put into it? Anywhere between 5 volts and 40 volts. Got to be aware of how you're going to power everything, because it might not whatever you buy might not handle the power. From your flight controller board, it's being powered from here. Yeah. Red, power, black, earth, yellow signal. All right. And that's hooked up just to my camera. So my camera outputs, it's got ground, it's got, you probably can't see it, but just there, it's got ground, it's got VBAT. It's got VBAT. Yeah, VBT, ground, and then camera 1, because you can have more than one camera. Camera 1. So VBAT. What does VBAT mean? Voltage coming out of your battery compared to other voltage sources coming off here, which could be just be 5 volt, and they'll be labeled. But V battery, if I'm putting a 3-cell lithium polymer battery on there, which is 11.1 volts, 3 times my 3.7 volts per cell, 3-cell battery, and that's 11.1 volts. Right, I'm having 11.1 volts coming out along that power there. And if that camera can't handle that, this one can, but if it can't, that's there. From speed controls we've done, that's all good. So this just here, what are the bits and pieces is your ultimate question for this. So this is what I've got. I bought them from Phaser FPV. Bear with me, I'm going to go edge. Sydney-based company. So I got these ones from, but I don't buy everything from Phaser. I also buy stuff from Buzz, FPV over in Perth. Let's get some stuff from China. And there is, what's that other company? There's Impulse RC for your micro apex frame. Okay, there's Phaser. Okay. And you can get all your stuff there. So when you hover over each particular thing, batteries, radio, okay, receivers, radios. I got Crossfire transmitter. I actually got for mine. I actually got I actually have a FreeSky X Lite. Now this is an X Lite S, my one. And FreeSky talks to the receiver on what's called the FreeSky protocol. If you bought a Spectrum transmitter, it would be Spectrum protocol. How the devices talk to each other. How the FreeSky transmitter talks to the FreeSky receiver on the aircraft, on the drone. So there's the X Lite there. You got the 3 brands. There's the X Lite, there's the X Lite S, and the X Lite Pro. An X Lite S you can charge through the USB. Got these funny 18650 lithium ion batteries that go in here, but you can charge the USB. There's a few more buttons and things. I think they're better gimbals too. So that's FreeSky, FastSky, but what you can do is, I did have a FreeSky receiver on here, but I wanted to go to TBS Crossfire for the iNav iNav part. Now TBS Crossfire, they all allow telemetry back from, so the receiver does transmit as well back to your transmitter that you're holding. But this is sort of long range, and it's a really solid link. It's really, and I found this out when I had a FreeSky receiver on, using a FreeSky transmitter. I went to failsafe a couple of times when I went behind like a little hill and other places. It lost radio signal, went to failsafe and just landed by itself. But this has been rock solid. I can go further, and I can go into more like areas where other radios would fail and you'd lose the connection. It's a TBS, and there's ultra low latency, so I think about turning and it turns. There's no latency at all. So getting back to what that means, if I go to radio, if I went here for radios, right, there's actually, I'd buy that if I had the money, TBS Team Black Sheep Pro, and that would talk to that little receiver, but I don't have that. All right, these are good, Radio Master and Jumper T16, T18, but I've got in my FreeSky receiver, I've got a TBS module that clips in the back. I don't have it here to show you, but it's cool. And some of these radios, rather than just having their own protocol that they transmit on, like FreeSky will transmit on its FreeSky protocol, like I said, and Spectrum will transmit on its Spectrum protocol, and Futaba the same. Some of these radios are multi-protocol. So, like those first lot of radios, you can put modules in the back so that a FreeSky radio can also transmit. It's an extra box with an antenna sticking out, and your radio transmits through that other brand. Right? It's like an English person with this, let's say this Chinese module clips on the back. When they talk, they speak Chinese automatically, and you don't have to do anything. Well, the software inside does it all itself. So I've got an X-Lite. And I've got a module. It looks like that, but it's for TBS. It sits on the back, it clips on the back, which is really, really good. I wonder if I can get a picture of it. There, okay. See that? So there's a FreeSky, which uses a FreeSky communications protocol with the TBS module on the back with the TBS antenna on it. So therefore, I would have to put a TBS receiver on. And they're all available through Phaser FPV. And you can get everything there. And all these guys would sell different, some vendors would sell some things, other vendors would sell other things. Okay. So, there's buzz, impulse. Ooh, micro picture, nice. Right. So there's what I bought from Impulse in Sydney. Now, motors, all right. I know they're propellers. I've got different size propellers, different colours. I like putting like a lighter colour propeller on the front, 2 motors, and a darker colour on the back. Doesn't matter as long as, it just helps with orientation when you're learning to fly. Propellers, motors, got 5 of those. If you can see that, 5 of those. In case I burn out one, I haven't. And there's the GPS, there's the electronic speed controller and power distribution board just there, one off. Some batteries. Batteries. Bear with me. There's a Panda RC 5.8 gigahertz video transmitter. There's the camera. That was an extra flight controller. That's not included. So you don't need that because I've just got the mini. There's the mini there, so you need one of them. I've got another one. I'm going to put that in a different drone. There's my TVS Crossfire TX Lite. That's the module that goes on the back of the FreeSky transmitter. Not cheap, but you know, I'd really consider just from now on staying with for myself with TVS Team Black Sheep for all my radio equipment. So I'd go out and buy a TVS transmitter and TVS receivers. So there's the Nano there. So really, that's the whole list. You can take a screenshot of that if you want to use that, like that. And I just didn't need the bigger flight control. I went and got the mini. All goods. Yeah, that's there. Sorry about that. So I think that brings us to the end of everything about flight controllers and the components and UARTs and ports and the equipment where to buy. So the next, that's been a long session. But the next thing is soldering. I'm going to shorten these wires here. All right. I'm going to shorten some of these wires because they're too long. I'm going to resolder. I'm going to give you some little soldering tips and points. Get everything connected, get it mounted down, put the frame back together, have everything hooked up, and then start configuring in beta flight. And after we've done that, we'll do our final checks and we'll fly it. So thanks for your patience. Hope that's helpful in some way. It's a long journey. Don't think you're going to master it straight away, but just persevere and hang in there. Big picture. Cheers. Bye.